So good afternoon, everybody. So this is Qichen Yang from the EC department, and I'm also a member of the RISE Center. So my lab is the power electronics and the insulation technology lab. So as you can see that the primary focus is power electronics and insulation technology. So let me provide more details about the work. So the primary research target is next generation distributed energy systems, which contains a lot of emerging new load and new sources. For example, we have from the south side, as you know that we already have a lot of renewable energies which has a very different features from the conventional power plants. And on the other hand, so we also have some emerging loads like some EV, a lot of EVs, and some AI data center. As you know that all of these are very energy consuming. So to fit this change, we need some next generation distributed energy systems, which should be completely different from the conventional centralized energy systems. So as you can see that energy is our focus, but what I want to say is that our research focus is definitely not only energy. First, to control these large and complex energy systems, we need some emerging information technology. Actually, as Qichen mentioned just now, actually the quantum computing is one emerging technology that we can apply it into our next generation energy systems. And in addition, these energy systems is a physical system as well. So it needs some material to support that, which means that some emerging material science and engineering technologies are also important for us. So it's also material systems. So in other words, so our system is actually although the primary focus is the energy network, we also need to pay attention on the emerging information technology and the science and the material science and engineering advancements. So for me, my research area can be summarized into three thrusts. The first one is the power electronics converter and the solid state or hybrid circuit breaker. That's the most straightforward and the most typical work in the energy network. And in addition, to ensure that our power electronics converter and the circuit breaker can have the high reliability, can have the high energy density. So we need to consider our insulation structure carefully, and we need to monitor the insulation status closely. So, and this part of work has a lot to do with the material science and the manufacturing method. And in addition, to control our power electronics converter systems and with the new sources and the new load, we also need some advanced control methods. This will be closely related to our next generation distributed control systems. So this is the background of the overview of my research. I will provide more details in the following slides. And about my lab, of course, I'm a PI, and right now recently, I just hired two undergraduate students, Andrea and Sean, and I'm still actively recruiting the graduate student and postdoc to build our lab and research together. Okay, so now let's provide more details about my research. The first topic is about power electronics. Basically, that's the hardware joint of the next generation power systems because it can control the power flow. It is the interface of the renewable energies and the interfaces of the new load. And in addition, it also provides some fast and smart protection to the whole systems. So here are some examples of the existing work. So one was a postdoc and the research faculty. I'm the technical team leader to build the 250 kVA modular multi-level converter, an emerging type of the multi-level converter, especially used in the medium voltage and high voltage systems. And this is a 12 kilowatts, 2 kiloamperes DC circuit breaker. So we developed this one for some emerging electric ship systems. This is the first area. And in addition, the second area is about the insulation technology. So that's that we discussed just now. So it supports the reliability of the whole systems. And actually, when we talk about insulation, we have to talk about the high voltage and the high electric field because that's one major issues and considerations for our insulation structure design. So here are some examples of the existing work in this area. So this is the PCB bus bar that I designed based on some comprehensive consideration in the insulation area. I will introduce that more later. And here is an example of the partial discharge testing of electric machines. So this is an example of the health status monitoring. And actually, you can see that this is some ultraviolet light. We use some special method to to visualize this part. This is also some surface discharge, or actually this is the partial discharge. And in addition, to ensure that our systems, our hardware can have a smart brain, so we also need to develop some advanced control method. Some of them needs to depends on some conventional analytical method. So, for example, this is an example of the analytical based conventional analysis based or physics-based stability analysis result. And of course, as you know that recently the data-driven method is become a very popular topic, and we are also exploring how to use a data-driven method to improve the performance of the systems. So here is an example about how to use a clustering algorithm to detect the fault in the power electronics systems. And in addition to these, and another point what I want to say is that in addition to the power energy systems, our technology can also be used in some other areas. For example, in the medical areas, some people use a high voltage to create the actually not very high, not so high, but relatively high voltage to develop some electrosurgery technique. Basically, we can use some converter to generate some electric pulse to cut and seal the skin, and then to help us to have some high accuracy surgery. And in addition, for the large scientific equipment, people also use especially high voltage technology. For example, in the SEM or some cyclotron equipment, people use a high voltage to generate the electron beam, and people also use some power electronics technology to develop some modulator for the tokamak equipment. So what I want to say that in addition to the energy systems, our technology can also be used in some other various multiple different areas as well. Okay, now let's dive into more details of my research. The first one is about insulation structure design. As you can see that this is also a comprehensive, we need some comprehensive considerations. So first, based on the dielectric physics, we need to understand, we need to provide some theoretical support of our design, theoretical criteria for our design. For example, here, based on some physics theories, we develop some criteria to evaluate what is partial discharge inception electric field. Basically, if the electric field is higher than this threshold, then there will be some surface discharge. And of course, and then to ensure that our electrical field can be designed well, which means that the electric field will not exceed this threshold, we need to care for consideration about how to manage our multi-physics fields, including the magnetic field, mechanical field, electric field, and temperature field. And sometimes these fields are coupled together, so that's another challenge we need to consider and solve. And of course, we also need to consider the material properties, like its insulation capability, its temperature tolerance, if it's mechanical strength. And so these are some. We need to consider these three area issues together in an iteration way. After that, we can provide a prototype to make it. And after that, we need to measure its parameters to verify our design, and we need to apply some partial discharge test and aging test to ensure that first, our prototype have the good performance, have the high quality. On the other hand, during this aging process, we can monitor, track its aging process. We can understand when we need to replace that, and if it's still good or not. What is a lifetime it should have, something like that. Okay, and here is another examples about the insulation area research. Is about insulation status monitoring. Of course, there is a very comprehensive insulation status. Contains a lot of phenomena. But here, I selected one typical phenomena, the partial discharge. But this is one one significant factors of the aging. So as you can see that, of course, we can use some optical method to detect that. But if we want to extract some more precise information, we need to use some more accurate method. So here is some measurement result based on the HFCT, the high frequency current transformer. And then you can see that we get a lot of pulses during this aging process. And here are some challenges. First, because actually the magnitude of the pulse is not very large, so we need to differentiate the noises and these partial discharge pulse. Recently, conventionally is not that hard because conventionally our power systems are just based on 60 hertz frequency, so it can be relatively easy to discharge to separate the noise and the partial discharge signals. But recently, because the power electronics power electronics converters are used more and more in the power systems, so the power electronics converters can generate some high frequency noise by itself. So how to differentiate the power electronics converters noise and the partial discharge signal is another challenge we need to consider. So we already have some work on that. So we need to improve both the hardware and the software. Okay, and after the insulation area, let's move to the power electronics area. So the first the first subsection of the power electronics area research is about the converter design. So here is one of my focus, the modular multi-level converter, a relatively new converter. So, and the first part about the converter research is about the analysis and control method. As we mentioned at the beginning, so we can use some analytical ways to analyze its performance, and then propose. Of course, it means some long equations, and then we can get. You can see that our ripples are suppressed significantly. That's one example of the good performance of a good improvement. And another method is another type of the method work is about the data-driven method. So here, as I showed in the first slide, we use some clustering algorithm to try to detect some fault modules in the systems, and then which can be helpful to improve the reliability of the whole systems. And in addition to the analysis and control, we also need to build our hardware. So this is a picture of the 250 kVA MMC that we built, and my work is to build the power circuit hardware. So, for example, this is some module that I designed. So, one point is that in this task we use the 10 kilowatt silicon carbide devices. This is a very emerging high voltage devices, which will, of course, right now, this product may not be very mature, but based on our application and our research, we realize that this new type of the devices can definitely have some great potential to change the world in the future. So, and here I showed some more detailed consideration process about how to design this type of the converter. So of course we need to characterize some parameters and use some analytical and the empirical way to evaluate its performance, and we need to have some field analysis as well. It can either based on the FEA analysis or based on some analytical analysis. And of course we need some special technologies to test the systems. And one point is that so because our energy is kind of high, so you can see that some of the voltage and current is not small. So we need to pay a lot of attention on the safety and the production facilities when we have these tests. So that's another important topic. Okay, and in addition to the circuit breaker, in addition to the converter, another important power electronics component in the next generation energy systems is the circuit breaker. So here is the example of the system circuit breaker that I lead to build. So you can see that basically it can achieve some zero current opening, and we applied some both analytical analysis and some numerical analysis on some important components like an inductor. So and this is another example about how we can another example about our lab's research in the power electronics to improve the performance of the future energy systems. Okay, and here is some collaboration and plan part. So first, what I'm expecting now is that because we want to develop some next generation partial discharge sensing technology, so I'm trying to collaborate with some researchers, some colleagues with some special expertise in the sensors. And in addition, because we wish to develop some new type of the insulation, so I'm trying to searching for some 3D printer for the polymers. And of course, because as I mentioned, so some high voltage power modules, some high voltage devices will definitely have the potential to change the design philosophy of the converter. So we are trying to research some customized power module as well, and then that may need some sinter bonder. So that's some equipment or some expertise that I'm expected to collaborate with, and in addition, of course, as a collaborator, I can also provide support to your research. I can provide customized power supply design, magnetic component design. And in addition, after we finish building the lab, I will provide some high voltage testing facilities, especially the high voltage pulse generator. I know that this will be very important for some physics design, and including something like the cyclotron that I introduced in the first page. And in addition, I can also provide some environmental chamber to adjust the humidity, temperature, and maybe vibration. Here you can see that this using and here is an example that of a very old cryogenic test setup that we used before, that we built about 8 years ago. Yeah, so to test some press pack high voltage IGBTs. So and of course, after we have plans to build some much better cryogenic test setup to continue our research in the cryogenic power electronics. So here, of course, I already introduced some possible research in the near future, and here are here is the summary. So of course, we will continue to develop the next generation solid state and hybrid transformers and the circuit breakers, and I'm also planning to develop some customized power module. And as you know that the energy storage system is a very important component in the next generation grid. So this system has a trend to have the higher and higher voltage. So the high voltage energy storage system is also another very interesting topics. And of course, some new application scenarios like the aircraft, aerospace applications, and some medical devices shown here will be also an interesting area for me. So thank you very much. I appreciate your time and attention.